Hi guys. About a year and a half ago, the star Betelgeuse, which is in the constellation Orion, started seeing a massive dip in the brightness of the star. And so astronomers were very excited about this phenomenon because Betelgeuse is a red supergiant star, and that means it's at the end of its lifetime, and people speculated that it might be going supernova perhaps any minute. Recently, people came up with a better explanation of why Betelgeuse's magnitude went down so much at the beginning of 2020. So to explain this, we have Anita today to summarize the results.
So hi guys, today we are going to talk about the mystery of Betelgeuse dip in brightness. So first, we could get a glimpse of what is Betelgeuse. It is the ninth brightest star in the sky and the second brightest star in the Orion constellation. Its magnitude is varying between positive 0 to 1.6 in absolute value. And for some reasons, its distance is really hard to estimate. For now, the best estimate about it is 600 to 700 light years away from the sun. And here is a comparison between Betelgeuse and other stars. As we could see, the sun looks really tiny in front of Betelgeuse. The Betelgeuse radius is 1,180 times of the sun, and it's about 10 times bigger than the sun. So let's going to talk about the Betelgeuse dip issue now. From 2019 to March 2020, the groups of astronomers find that the Betelgeuse becomes really dim. Its spectral radius could be in 1.0 to 1.5, as you could see in the picture in March 2020. But through this year, it becomes really dim, which its spectrum becomes like from 0.5 to 1.0. And how the astronomers observe the Betelgeuse? They are using the very large telescope. As we could see in the right picture, this is the station of EOS. This picture shows the light curves of Betelgeuse observed over the past 6 years. As you could see in the picture, the gravity observation and the sphere observation of Betelgeuse looks very strange during January 2019 to January 2020. So this makes the scientists to think about what causes the dim about the Betelgeuse. So the four assumptions the astronomers first think about are: the number one is a decrease in the effective temperature of the star, making it fainter. And the second one is an occultation by newly formed dust. The third one is an occultation by dust transiting in front of the star. And the fourth one is a change in the angular diameter. However, through the observation continues, the third and fourth assumption is rejected. And the really cause of the dim of Betelgeuse is a combination of assumption 1 and assumption 2.
So you were going to say something? Oh, I had a question.
Serious question.
Yeah.
Occultation means
Like
just something is blocking
Or
the
covering.
light. Covering.
Yeah.
Okay.
Yeah.
Where does the dust come from?
For the second one, the dust is formed by the Betelgeuse itself. It's like some.
Like chunks of Betelgeuse are just...
It's like it ejects some gas, and when the gas are cooled and the dust is formed. And for the number 3, it's like maybe some dust from other places. They're moving around the star.
Okay.
Yeah.
Someone should really vacuum clean that place. You can remove it later.
And so we'll first talk about the assumption 3, occultation by the dust transiting in front of the star. This is rejected because, as usual, if a dust is covered around the Betelgeuse, then we will see that the darkness area of the Betelgeuse will constantly changing about in the quadrant. However, in the picture of the observations, we see that the darkness area in the Betelgeuse doesn't change the quadrant. They're still in the same place. So because of this reason, the assumption 3 is rejected.
So hold on. So quadrant just means what? You
Yeah.
split the picture into Borders.
Yes. So it's the darkness part is always at the southwestern part in the picture. If there is a dust transiting in front of the star, so like for now, the darkness area will be at the like left bottom part, and then it will changing into, for example, like right top part.
Like clouds
Yeah.
going across the image.
And then we'll talk about the rejection of the changing the angular diameter assumption. To verify this assumption, the astronomers measured the uniform disk angular diameter of theta. Use the following formula. I will explain some of the part of the formula. So as we could see, I don't know how to read that. Yeah, this one.
So,
It means the angular radius measured from the center of the apparent stellar disk.
but is it Greek or Latin?
I don't know how.
That's also theta, isn't it? Isn't that theta?
Yeah, it's theta. I think it's
Yeah.
Greek. I think it's
Okay, Greek theta.
What is the
math?
what is the var theta?
I think so.
Oh yeah. But, slash VARTHET.
Yeah.
And this part, this IV theta part, is the variation intensity across the stellar disk. And this part, V over C, it is the frequency of light used to make the observation. And
So that's a Bessel function.
yeah, that's Bessel function. So use this formula, the astronomers finally calculated the theta for January 2019 and February 2020s. They find that the values are very close. The one is 42.61 and the other is 42.11. So that means that there is not a huge change in the angular diameter. So the assumption 4 is
So,
rejected.
hold on. Angular diameter. What are we trying to actually? What angle are we trying to measure here?
The Betelgeuse is a sphere-like.
Yes.
So we calculate its diameter. If the diameter changes a lot, it means that its self-change in the angular diameter causes it becomes thin.
So we're thinking that the size of Betelgeuse is like getting like super big or small, like it's fluctuating. Okay, so but it doesn't look like it's getting any bigger or smaller.
Yeah, it's still the same.
So do we need such a complicated formula to say that? I mean, why can't you just look at it and say, oh, it's bigger or smaller?
It's just like the formula they use to calculate the angular diameter. Maybe it's just for more serious.
Okay, it's for more serious people than us. Yeah. Okay.
And finally, they find out that the theme of Betelgeuse is a combination effect of the first and second assumption. For test the first assumption, the cool patch hypothesis, they use a composite phoenix model. And to test the second assumption, the dust clump hypothesis, they use dust radioactive transfer simulations. So based on the telescope image calculation and the existing knowledge about Betelgeuse, the researchers now find that the star first emits a large gas bubble, and then the part of the star surface cooled. This caused the gas bubble to condense into a cloud of solid silicate particles. Then that dust cloud overshadowed the star like a kind of dust veil. So it means that the Betelgeuse itself ejects a large gas bubble, and the cool down of it result into a newly formed dust in front of the Betelgeuse, and this newly formed dust covered some light of Betelgeuse. Researchers think about that it might attribute it to the pulsation or convective activity so that the dust disappears. Also, they noticed that the Betelgeuse experienced a large mass loss through this ejection of gas clumps. Because of Betelgeuse is losing its weight, it also comes to the question that will it explode and becomes a supernova? And will it becomes a second sun if it's explode? And the answer is no, because based on the light curves and spectral line variation point of Betelgeuse, it does not fit into a model that which a supernova will have. However, the scientists said that it's also really hard to see whether the Betelgeuse will explode it without any warning. According to the evolutionary model, its energy released at the point when it's explode, it's equivalent to the energy produced by the sun in its entire life.
Oh, wow.
It's 1 second energy is equal to the entire life of sun. And it will generate kinetic energy up to 2 multiplied with 10's power of 44 joules.
How much is it in kilocalories?
I think from the perspective of Earth, its apparent brightness produced by the supernova explosion will equivalent to the brightness of the full moon. And for the exploration of the Betelgeuse is also very hard to say because as Betelgeuse is becoming a supergiant for 40,000 years. So it is really hard to say. Maybe it will explode in the next 100 years, or maybe it will explode after 1,000 years.
Right, thank you. Questions?
Why do we really have to study Betelgeuse? Since it's many light years away from us, and if it explodes, it doesn't really affect us. Of course, there must be a reason. So why are we really looking at it?
Wow. It's just science, right?
I think maybe we didn't experience a lot of supernova exploration of the stars, and when astronomers noticed that this Betelgeuse, which very far away from us, is becoming dim, so they think that it might become explode. So maybe the more they're interesting about is the exploration of the Betelgeuse.
Actually, come to think of it, the explanation is really weird because, okay, so even if it's like kind of a pretty cooled down star, I would actually expect it's all gas. It's not like a ball of like water or something. You go glop, It's like gas, right?
Yeah.
So what do they mean a bubble? A bubble of what?
Gas also can have a bubble.
Gas can have a bubble? Can it?
Why not?
Some kind of that.
How?
It's like a region of other gas inside of gas. I don't know.
Unless if it's liquid, that's when you start having bubbles. Or fluid.
It's not a liquid,
Gas is
right?
fluid. It's not liquid, but it's fluid.
Yeah, but it's not a bubble.
Right. I mean, what is a bubble?
Why the bubble is round?
Become vacancy.
Well, yeah.
Yeah.
But I mean, it would be filled with some gas, right? It sounds like there's some gas, right?
Yeah.
Or some like low density, just a continuous area of low density, like compared with the rest, it's like pretty low density gas.
And then they just filled it all of a sudden one day, and then
The other day it expands.
Seems pretty weird, actually. I don't know.
well, we're not
Yeah.
astronomers, so
No.
maybe this is weird to us. But
Yeah, maybe gas bubbles.
Maybe we are weird. Tim, have you read out like anything about like using like you can use like actually BECs to like you can also have like a boson nova thing.
Oh yeah.
Can we use BECs to simulate such such
Yeah.
bubbles?
well, we shouldn't laugh because maybe this isn't the next breakthrough.
Well, yeah. Well, so this boson nova, I think, happens when you change the interactions
Yeah.
of the bosons, and then all bosons like to all clump together anyway, right? But then if you suddenly change it, and then so it's an attractive force, then there's like even more reason for it to clump together. But it just clumps together so much that it sort of explodes again. Yeah. So they called that a Bose nova. I mean,
So, can you experimentally realize that?
well, no, they saw that experimentally.
Yeah. Oh,
Yeah,
okay.
yeah.
Cool.
So that's quite a interesting effect. Okay, so who says Betelgeuse? Who says what was the British way of saying it?
Betelgeuse.
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 I the British way. Betelgeuse.
Betelgeuse.
Sounds more fancy.
I like Beetlejuice because it reminds me of the movie.
Oh yeah, the movie was great. Okay, now I don't know.
I mean, they both sound ridiculous to me, actually. Beetlejuice sounds ridiculous. Also,
Tim, what do you call it?
Betelgeuse. Well, I don't know. I had to look it up. So,
Why don't we just call it Dave?
yeah. I even had to look up like the site of Australian pronunciation of Betelgeuse because I was like, well, do they go with the British one or do they go with the American one?
Do you like add O in the end or?
There were 3 videos and they said it in the more American way. So,
Oh.
oh, what does that mean?
Sounds like Australia has chosen sides.
No. No. Yeah. What's the Chinese way of saying it?
参宿式
Oh, okay.
Yeah.
Whoa.
Okay.
参宿式 哦，参宿式
Where we have a dispute.
So that's the American one,
Yeah.
and this is the British one.
No, it's like you have like one county but like different pronunciation.
Yeah.
And what does it mean?
It's from like Asian Chinese constellation naming method, I think.
Okay. Well, Merrick's looking at his phone now, so I guess we might wrap it up.
I was just checking Polish.
Oh, I
What
see. I
did they
see.
say in Polish?
It's Betelgeuse.
Ooh.
Ah, Betelgeuse. Why do they make it such a complicated name? It's like almost,
Exactly. Just call it Betelgeuse.
yeah,
Great presentation.
Oh,
Thank
yes.
you.
Thank
Thank
you.
you.
great. Yeah.
No. Last time when I clapped, Tim said to not clap.
Thank you, everybody, for your attention. And if you like this video, then please don't forget to subscribe to the channel. And we'll see you next time. Bye.